All right, so in this unit, we're going to start talking about terminal angles, coterminal angles. We're going to talk about radians, degrees, and we're going to do a lot of work with the unit circle. So in this lesson, we're going to start talking about terminal angles, how we measure angles, and then also converting between radians and degrees. So a couple things that we want to be very clear about. You can measure angles as a rotation. Okay, so it sounds a little bit weird, but basic idea here, and I'm going to zoom in on the first one, is we have the initial ray. There is some amount of rotation that we've done, and we have a terminal ray. Okay, so the initial ray is where the angle starts. Most of the time, that would be the positive x-axis. If we can make that work, that's what we like to do. The terminal is where your angle terminates or ends. Okay, so that's why mathematicians are not creative. Initial is where it starts, terminal is where the angle ends. I can't tell you where it ends because every angle is going to be different. All right, but generally we consider the initial to be the positive x-axis if we can make it work. All right, a little bit of weird stuff, at least visually. Positive angles rotate counterclockwise. So if we look at this angle here, we have this initial ray. It is counterclockwise some amount. Let's go ahead just for giggles and say that's 70 degrees. All right. Obviously, I'd need a protractor to truly measure it. I'm not going to worry about that. Negative angles rotate clockwise. So this is going to be a change because up until this point, you've probably been told repeatedly, I know I've done it to my students, that we don't have negative angles. Oftentimes the reason we say that is because when we talk about a physical triangle or a square or some kind of shape, we're talking about an angle that has to have a positive measure. When we talk about rotation as an angle measure, it is absolutely possible to have a negative rotation. So in this case, rotating clockwise or counterclockwise. Now, what's going to happen here is if we've got a 70-degree angle, that's the positive rotation. You could also measure this in the in the clockwise rotation, and that would be negative 290 degrees. Now, how did I get 290? I took 360 minus, or 70 minus 360, because there's 360 degrees in a circle, or in a full rotation. So 360, and I took 70 minus that amount. Okay. So we can also have angles that are much larger than, let's say, 180 or 90 degrees like we're used to. Again, just depends on the problem. So this one is starting at the initial, rotating counterclockwise. So we're going to say it's positive. Let's go ahead and say that's 250 degrees. Okay. Now, if I want to find the negative rotation here, which would be the negative angle or the clockwise rotation, I would start at the initial, rotate clockwise. So take the original angle, subtract 360, and I get a feeling, is that 110 degrees? Yeah, that sounds right. Or negative 110. All right. So each angle you'll notice has two measurements, and there's actually more than that, but we're going to just start with two for right now. All right, where else are we going to here? So two different angles here. We've got the positive counterclockwise rotation. And again, this initial ray, if you notice, all of these look like they could be the x-axis, and then the terminal ray is wherever the terminal ray is. So I'm going to say that this is 280 That is horrible writing. Let me try that again. 280 degrees. Okay. And so what I have here is, yeah. If I were to then figure out the negative angle, the clockwise rotation here, take the 280, subtract 360, and I'm left with negative 80 degrees. All right. So you'll notice again, each one of these angles has a positive angle measure, that's the counterclockwise, and a negative angle measure, which would be the clockwise rotation. So if you want to, take a moment and try to see if you can match up angles A, B, C, D, and E with the possible measures that they have. Feel free to pause if you want to try this on your own. I'm going to go ahead and jump into it. So let's see. This looks a lot like a 45-degree angle, so that would be D. So there's 45 degrees. Let's see. That's that one. 270 is this angle right here as a positive rotation, 270 degrees. Let's see, negative 120 would probably be this one right here. That's going to be negative 120 degrees. So that's answer C. Oh, let me put the 270 here as an actual letter value. That was B. So that leaves me two more. So this is a little bit more than 90 degrees, which would be the right angle. So I'm going to say this is 100 degrees. So that's going to be A. And negative 200 is going to be a little bit more than the 180, which would be the straight angle. So if I rotate a little bit more clockwise, that would be the negative 200 degrees. And that's answer E. So D, C, A, B, E. Now I want you to take a moment and figure out the other rotation. So in the case of angle, or this first picture, I'm not going to say angle part A, but this first picture, we have a positive 45-degree angle. So the question I would ask is, what would be this same angle as a negative angle value? So if you want to, again, pause and figure those out and then check back. So I'm going to take 45 minus 360, and I've got a calculator sitting next to me. So this angle would also be, whoops, let's try that again, negative 315 degrees. And again, that's the positive clockwise rotation. Second triangle, or I keep calling them triangles, second picture here. Let's get the positive angle rotation. So I'm going to do negative 120 plus 360. It's negative 120 plus 360. I'm going to get 240 degrees. That's the positive. Let's see, positive 100. If I rotate in the clockwise, it would be 100 minus 360. And that's going to get me negative 260 degrees. This was, what was that? 270. So let me label this one again. 270 degrees. So if I'm trying to find the negative rotation, so it's clockwise rotation, I take 270 minus 360, which I'm pretty sure is 90 degrees. In this case, negative 90. And last but not least, I wanted the positive rotation attached to negative 200. So I'm going to do negative 200 plus 360. 200 plus 360, so positive 160 degrees. All right. So that's a little bit about terminal angles, coterminal angles, or we'll get to coterminal more in a little bit. But so you'll notice for each one of these, I either added or subtracted 360 to find the other angle value. So that's something that's going to be important as we look at some other answers. All right, degrees and radians. One full rotation in degrees is 360 degrees. 1 full rotation in radians is the circumference of a circle with a radius of 1, which basically turns into 2 pi. So 360 degrees is the exact same thing as 2 pi radians, and we're going to use that to convert between degrees and radians. If you have degrees and you want to convert to radians, you are going to multiply by pi over 180. If you have radians and you want to convert to degrees, multiply by 180 over pi. Now, how did we get those? Well, if we take the 360 equals to 2 pi and we divide both sides by 2, we end up knowing that 180 degrees is equal to pi. And so we use that conversion as their equivalent. So multiplying by pi over 180 or 180 over pi is the exact same thing as multiplying by 1. So that's the idea behind the conversions. So problem number 1, we are converting from degrees to radians. So that means I'm going to take each one of these and I'm going to multiply it times pi over 180. Now, do not, well, you can put part of this in your calculator, but don't put the whole thing in. So let me go ahead and pop up Desmos. I'm going to use that as my calculator here. I'm also going to get rid of what I already had because that's not terribly useful. So what I'm going to do in Desmos is I'm going to take 150 divided by 180. Now I'm going to ignore the pi for right now, just because I'm going to. So 150 divided by 180 is a decimal. But if I click this little icon right here, you'll see how it's the numerator over denominator. It will convert my answer to a nifty little fraction for me. So this is 5 pi over 6. That is the radian angle measure for 150 degrees. So how about the next problem, which would be 330. So I'm going to do the exact same multiplier, so pi over 180. So I'm going to take 330 divided by 180, convert that to a fraction. So this would be 11 pi over 6. Now, the reason I'm not putting pi in my calculator is because pi is a nifty little decimal that does not repeat and it does not terminate. And so it doesn't work too well when we're trying to deal with fractions in a calculator. So 540 degrees times pi over 180. So I'm going to do 540 divided by 180, and that's just 3. So this turns into 3 pi. And it's one of those things, you can have angle measures that are much greater than 360, and you can have angle measures that are greater than 2 pi. It just depends on what you're doing. Remember, because we're talking about rotation. So rotation can be greater than just 360. So if you were in a spinny chair and you just spun around in circles, you could spin multiple times. Question number 2, we've got converting radians to degrees. So instead of using pi over 180, flip it over 180 over pi. Let me zoom in just a little bit here. So what'll happen with your radians is when you're converting them, pi and pi will cancel, which is what we want. And what I'm left with is 180 over 9. So if I do 180 divided by 9, I get 20. So pi over 9 is 20 degrees. So keep doing the same thing. 3 pi over 5, I'm going to multiply times 180 over pi. So the pi's will cancel out. I'm going to take 3 times 180 because those are both in the numerator, and then divide by what's in my denominator. So divided by 5. So that is 108 degrees. I'll get that in a minute. And 5 pi, so I'm going to do the same thing. So times 180 over pi. So pi and pi cancel, and I'm going to do 5 times 180 equals 900 degrees. Now, you can't draw a 900-degree angle in a triangle. Doesn't work so well. But when we're talking about angles as a rotation, totally makes sense. You just keep spinning around. I'm going to go ahead and close off this video for right now. I'll do page 2 in a separate video. Please let me